Alright, just take a note of what graph this is. It's speed versus time. So it's a scalar. Graph is not to scale. So what we have to do first is describe the motion of the object throughout the 13 seconds. So pretty much you have to describe all the little sections. There's section 1. I just always like to, separate them into separate sections. So there we go. Alright, section 1. So from 0 to 2 seconds, what happens is the object accelerates, because that's what the slope means. It accelerates at a constant rate until it reaches 10 meters per second. Now, then what happens is the velocity is 10 meters per second for 1 second, because 2 to 3 seconds is 1 second. And then for the next 4 seconds, over here, 3 to 7 seconds, for the next 4 seconds, it accelerates to 20 meters per second. And then what happens is then for the next 3 seconds, when time is 7 to 10 seconds, section 4, that is when the velocity stays constant and is just 20 meters per second. Alright, last section 5, for the next 3 seconds, so the velocity, the speed decelerates from 20 meters per second to 0 meters per second at a constant rate, meaning, the deceleration is constant, because obviously you can see that from the straight lines. Alright, B, determine the greatest acceleration experienced by the object and justify your answer. So basically, for part B, what you have to do, you need to figure out the acceleration, which you do by looking at the gradient, the slope. Remember, the gradient, or the slope, is going to give you an acceleration at a speed versus time graph, or a velocity versus time graph. So let's have a look. Just looking at it, it's obviously either going to be 1, 3, or 5, because 2 and 4 doesn't have any acceleration, as the velocity just stays constant. So we just got to figure out which one has the steeper slope, basically. And you can just do that by doing the acceleration equation. So I'm just going to write section 1. So, it doesn't matter how you label it. You can write 0 to 2 seconds. But I labeled it, so I'm happy to use section 1. My A is delta V over delta T. So my V goes from 10 take 0, and my time was 2 seconds, which is 10 divided by 5, which is 5 meters per second squared. Section 3, because 2 is constant. Same thing. Just do the acceleration equation. So this is 20 take 10. Time is 3 to 7 seconds, which is 4 seconds. So that is 10 divided by 4, which is 2.5 meters per second squared. And the 5th section. Now you just got to be careful with this. This is speed versus time, so you don't have to put any negative signs. But let's see. Delta V, so my final is 0. My initial is 20. Time is 3 seconds, so that's 20 divided by 3. Which is about, I forgot a negative, which is about negative, I think, 6.7 meters per second squared. Now, looking at all of these, we kind of have to compare them. So I'm just going to highlight the ones that are the accelerations. Now, you might think 5 is the greatest acceleration, but negative 6.7 meters per second is actually the greatest, because you actually just look at the size, not the direction. So plus, minus doesn't matter. The one that has the greatest slope meaning the greatest acceleration is going to be the one with the greatest number, disregarding the plus and the minus sign, because that's just going to give you direction. So basically my answer is section 5. So my answer would be the greatest acceleration would be negative 6.7 meters per second when time is 10 to 13. So that's what I would write. Alright, determine the distance travelled by the object in the 13 seconds. So that's the whole thing. Alright, they gave us the fact time is 13 seconds and we want to figure out the distance travelled. Obviously we're going to need the speed. Alright, so the speed is, oh, so actually that one, my bad, we don't do that. Determine the distance travelled. So if we have a speed versus time graph, the slopes of the graph give us, maybe I'll write it here, slope gives us the next value, which is acceleration, and the area under the curve. This gives us distance. So for us to figure out distance, total distance, we just have to figure out the area under the curve, and what you can do is kind of split it into 5 different sections or whatever sections you like. Obviously there's already 5 different sections kind of noted, so I will just split it like that and I'll probably just add them up like that. Alright, so the first one is 2 by 10, but it's a triangle, so I've got to divide it by 2. So area is, you know, section 1 plus 2 plus 3 plus 4 plus 5. My area 1 was, I think, 2 times 10 divided by 2. Let me just double check that. Yep, maybe I'll just zoom out a bit. Alright. Next section is 1 second times 10, and it's not a triangle, so I'll leave it. Next section is a parallelogram, trapezium, so I have to add this side and this side, which is 10 plus 20, and then I have to times that by the height, which is 4 seconds, and then divide it by 2. And then I've got to go to the 4th section, which is just 20 times 3 seconds. And then the 5th section, which is 3 seconds times 20, but divided by 2 because it's a triangle. So if I just solve that, that is 10 plus 10 plus 30 divided by 2, 15 times 4, 60, another 60, and then 30, so if I add them all together that'll be 170, I reckon. And I'm just going to check that with the answer, and it's correct, 170 meters. And that's it.